All right, hey zoology. Um, Welcome to a little video about the subphylum Hexapodia. And today we're going to talk a little bit about flight. We know that insect flight really involves one of two possible modes of action, all right? We're going to talk a little bit today about direct flight mechanism and indirect flight mechanism. To maybe help you out just a little bit, if you want to refer to pages 16 through 17 in your packet, you can. That shows some pictures, but really all the information you're really going to need is going to be in this presentation over the next couple of slides. So let's first of all talk a little bit about, here's our first type of flight. Again, remember there's two types. We're either going to be talking today about direct flight mechanism or indirect flight mechanism. I'm going to talk a little bit about what they are and then give you some examples. All right, the first type of flight that we're going to look at, you can kind of see off to your screen right there. And just kind of take just a second just to make a couple of observations. The brown and tan are representing the muscles. And so really my first question would kind of be like, where are those muscles attaching? Are they attaching at the exoskeleton, the thorax, or do you see them attaching at the wing? All right, to kind of help the wings move. So this type of flight is called, here's what I need you to get down. This type of flight is called direct or synchronous flight. And really, I just care about direct. We're just going to utilize the word direct, or maybe just kind of talk a little bit about direct flight mechanism. And so as you can see in direct flight mechanism, can everybody see how the muscles are directly connected to the wings, the base of the wings? That's why it's called direct. I hope that kind of makes sense. So check this out. Direct flight mechanism is when the muscles attach at the base of the wings, okay? And you can see like one set of flight muscles attaches just inside the base of the wing, and the other set kind of attaches slightly outside to the base of the wing. Okay, this does provide flight for lots of different types of animals, what we're going to talk a little bit about. But can you see how it requires two nerve impulses for an upward and downward stroke? All right, so that means probably you could probably see this happening within your eyes. Like you see animals that do this, insects that do this, you usually are able to see their wings moving up and down. Okay, some examples of insects that would do direct flight would probably be, you can see them down below, butterflies, dragonflies, and grasshoppers, and probably some roaches too. This is for more primitive insects, like we just mentioned. Okay, so just kind of keep this kind of in your head. Again, direct, one more time, is when the muscles attach at the base of the wings. The wings move, and two nerve impulses are going to be responsible for that. Okay, our next type of flight, if you kind of check this out, is called indirect or asynchronous flight. And just take a second. Can you see what's happening here? First of all, the muscles, can everybody see, are not connected to the wings, right? Can you see that? And when the muscles contract, what it does is it moves the entire thoracic region of the body of the insect, okay? And so the flight muscles kind of distort or the shape of the thorax, which in turn causes the wings to move. So if you look at this, I'm just going to go back for just a second. Can everyone see how the thorax is being highly affected when it's indirect? So go back. Check this out. Direct, not so much. Okay, just the wings move. So on indirect, the entire body moves. Or what I would maybe write down in our notes, in indirect, the muscles act to change the shape of the exoskeleton. Can everybody see that? Okay. And it does that for both strokes. So really, this happens really, really fast. And so for indirect flight muscles, what they allow are the wings to beat faster than neural transmission. Can everybody see that? Well, you probably can't. Like if we were looking at this in real time, you wouldn't be able to see the wings going up and down really fast. You wouldn't be able to see that. Um, in reality, most insects, the majority of insects really fly this way, and it is a little bit more complex. Again, the thorax really changes shape completely. And some examples of insects that are doing this would definitely be like flies and wasps. And so we've all seen that. We've all seen flies and wasps fly, or we hear them. And if you think about that, it's really, really, really hard to see their wings moving. And in reality, if we slowed it down, which now we have the capability of doing, you would definitely see their entire thorax would be moving to make their wings move. So it really changes the shape of the exoskeleton. The wings beat faster than neural transmission in indirect flight. And a great example would be flies and wasps on this one. All right. So, really, just to kind of sum up, insect flight requires more than a simple up and down motion of the wings for sure. But these complex movements help the insects achieve lift, reduce drag, and perform really these really cool aerobic maneuvers. So, it's kind of cool. Now, can all insects fly? The answer is absolutely not. But the ones that are flying, the ones that do have wings, are either utilizing direct or indirect flight. Okay, I hope this was helpful. Thanks.